Hi, I made this tutorial with the aim not only and not so much to implement a specific use case, but to help you understand the approach to the rapid development of solutions that exploit totally serverless components and managed by Azure, of course. The steps I'm going to show you now will allow you to reuse each of the components to quickly address very different challenges through the same architecture. The end-to-end scenario we are going to implement today provides that as soon as a new sentence, let's say a new message, arrives in the queue, its sentiment, which is the positivity value, is immediately and automatically analyzed, and then it's redirected to a new queue whose name will be good, bad or neutral depending on the score obtained by the service. And so let's start with the cognitive service. I chose sentiment analysis, which is part of the text analytics category. Here we see it already created, since the creation on Azure is just a matter of a couple of clicks. So we select the Quick Start blade and open the text analytics documentation in a new browser tab. Before reading the documentation page, we note the value of the endpoint, HTTPS North Europe API Cognitive Microsoft.com, which is quite generic, if not for the region. Therefore, the association with our cognitive service, as we will see in a moment, will be done through its private key. For now, let's copy the endpoint value and switch to the documentation page we have just opened in the new tab. And we see that we have, among the other available services, the sentiment analysis. From here, we could then choose the language and follow the standard documentation. But today, I wanted to do a more complete and faster tour, so I'll give you now some tips and tricks. Let's restart from the endpoint we copied. You remember North Europe Cognitive Microsoft.com. And in the URL, instead of API, we write dev. Then we open the link, and we are back in the developer portal dedicated to the cognitive services APIs. Let's follow the first link, and let's look for text analytics. We see several API versions, and we take the most recent one, which is version 3.1. And we select sentiment analysis on the left, while on the right the documentation appears with the URL to be called through a post-REST call. It's also possible to use parameters, which, however, as you see here, are in square brackets, which by convention means that they are optional. So we replace within this URL our initial endpoint, and we get this string. Let's now try it in Postman or Fiddler or your favorite tool to run REST APIs. We then look in the documentation for what are the necessary elements in the header, and we find that they are these two ones, content type and subscription key. In fact, if we don't insert them in the call, the service answers, but it correctly tells us that we have to authenticate. So we take the key on the portal, and then we complete the code with the two headers required. But we get a new error that still correctly informs us that the message body is missing. However, this means that we are getting closer. Once again, we look for this information in the documentation. We copy this text, which is in JSON format, into Postman, and we customize it. Now the sentence is clearly positive. This time the answer is 100% complete and correct, and tells us that the positivity level is maximum, while we have zero confidence regarding neutral feedbacks and negative feedbacks. This is important because it shows that in version 3 of this API, we have 3 independent pieces of information for positive, negative and neutral sentiments. If you have dealt with previous versions of this library, I'm sure you will appreciate this fact, because it is not trivial at all to have these 3 independent pieces of information in the answer, instead of just one, as it happened in previous versions of this API. We also note that this service is also able to read any number of questions, even with mixed different languages, as here, Italian and English. Well, now that we have seen how to invoke the service from Postman, let's try to invoke it from JavaScript. On my machine, I have already installed the Node.js framework, so I simply open a new console window, create an empty folder, run the npm init command, and I can also accept all the default values as the answers. Now we need to create the index.js file in the folder and fill it with a small code snippet that you see here. Let's quickly comment these lines. The first line informs the system that we will use the HTTPS module, which exists by default without the need for installing it. The first three variables match the values we have already seen in Postman for access key, endpoint, and path. The documents variable contains the body. The post request contains the header with the authentication key. The call to the function can have a second parameter with a callback function that in this case I wrote in line, as you see here, to log the response in the console window. If we run this program from the console, we get the output we already had before in Postman, and I would say there is no point in going into further details here. The focus of this tutorial is not the Azure functions, but it is nevertheless a prerequisite, so even for those unfamiliar with it, I will quickly give the steps to get to the result. Let's start by creating a function app, which is in fact a container of Azure functions. The goal is to reuse the code we already tested locally, so I select Node.js as runtime. The container will be ready in less than a minute. After that, we need to add our function, as we see here. We could then choose to develop the code in Visual Studio Code or with other editors, but for the sake of this test, we will write the code directly on the Azure portal. We remember that our final goal is to perform the analysis on the messages arriving in the queue, so we will use the template called Azure Queue Storage Trigger. Finally, we give a name to the function, we call it the triggered sentiment, and click on Add. Let's go straight to the function JSON file that Azure created for us. In addition to other details that it is not useful to delve into at this time, we note two things. The name of the JS queue items queue, in which the service will monitor the arrival of messages. So if you already have another one, or if you wanted to change this name, you can do it here. And the direction, which is in, to identify that the trigger will be listening for messages that are coming into the queue. Now, let's look at the index.js file, which actually contains our application. We already have its skeleton that we see here, in which we will simply have to insert before the last closing line the code we wrote before. Compared to the version we used for the local test, the only difference is in the definition of the documents variable, and then we force also the English language. We note that the parameter that the function receives from the queue is a string linked to the myQueueItem variable. This allows us to write in the queue only one string whose sentiment value has to be validated. The piece of code that we find below is a bit richer to handle any errors returned by the cognitive service. Well, let's save the file, and now we are ready to test our function, for the moment with the portal tools. If everything works, we will end this test by putting the value in the queue. Then we click on Test Run, we insert a positive sentence like I had a good dinner last night, and we see that it has 100% positive sentiment. Now that we have tested the function successfully, let's try it out on the field. Recall that the function configuration, which is written in the function JSON file, contains the name of the queue on which the function expects to receive messages, JS queue items. Then we open the storage account linked to the function and create this queue through the Azure portal. Now we have just to add a message to the queue. I will write, today it is a wonderful day, as you see, remembering that our implementation provides only the English language, although the service includes 15 languages, including Italian, of course. In less than 1 second, the function is called by passing it the sentence written in the message, which, as we see, is correctly interpreted. The monitor blade in the function on the Azure portal confirms that it has been correctly invoked. We can even see the same information, actually much more enriched with details, by launching Application Insights, whose link is located in the same window above. And we conclude this tutorial with one last experiment. So far, we have used the queue to read incoming messages encoded by the value of direction equal to in, you remember. Now we are going to define 3 other possible output queues. In fact, they will be used to separate messages of positive, negative, and neutral types. We note that the fact of having defined the queues here does not determine their creation regardless. These queues will actually be created only when a message is redirected to one of them. Now, that the bindings are defined, we need to add the code to send the messages into the body of the function. In practice, we must intercept the end event of the call response. We simply go and retrieve the sentiment value contained in the response JSON and use it to determine the queue which we have to copy it into. After that, the message will be automatically deleted from the JS queue items input queue. In fact, we see here that now we have 5 queues, including the input one, a system one, and then the 3 queues for positive, neutral, and negative sentiments we defined in our code. As mentioned earlier, the queues are all shown here only because at least one message has been redirected to them. Well, I hope this tutorial has helped convincing you of the opportunity to take advantage of this approach to rapidly developing solutions that leverage fully serverless Azure managed components. Try it and have fun!